Hi, welcome to Dissolve Chemistry. Let us continue our discussion on this chemical equilibrium. Okay, in the previous video, we have discussed regarding various applications of equilibrium constant, and also we have seen the relationship between Gibbs free energy, reaction coefficient, and equilibrium constant. In the present video, we will discuss regarding factors influencing equilibria. Okay, well, prior to going for what factors are going to affect the equilibrium, let us understand that why we are fond of knowing these factors. Okay, the first and foremost important thing is for any chemist is that if he is combining A plus B, okay, what these are A plus B, if he is combining means we call that as what reactants. Okay, if this combination leads to formation of the C, say for example, and C is the product, and always remember as a chemist, so always we are fond of the product, right? As we are fond of the product, the first thing is the A and B have the tendency to combine to give the product C. That is very important. Or to what extent they combine and give the product C. So that is the one thing. And second thing is this product C I must get with less expenses, okay, or less expense of the energy, efforts, okay, and what we call other equipments, whatever it is required, all that should be minimum we should use, and we should get maximum product. Okay, so that will be the always aim of any chemical to be produced. Okay, so of course, if the reaction is spontaneous and occurs under normal conditions of pressure and temperature, then no need to worry. We will get lot of product by the combination of the reactants. But it is not always or same for all the reactions. Okay, so therefore, say for example, very important, industrially important reaction, say for example, N2 combines with H2, formation of ammonia by Haber's process. It occurs reversibly and attains an equilibrium. Okay, so ammonia we need in millions of tons every year because it is used as a nitrogenous fertilizer or in the manufacturing of nitrogenous fertilizer, and as an industrial important chemical it is. Fine. So now, as it is having tendency to decompose back to give the reactants, then it makes very difficult to get more and more ammonia. Okay, and with less expenses we can say. Okay, so to enhance its productivity or to increase the yield of ammonia, then what I have to do, the equilibrium established in this reaction has to be shifted in the forward direction. To do so, okay, and that too with less expenses, then one must think that what are the factors which will govern this equilibrium, we must know. And those factors are very important factors will be what? One is concentration, and second one is you can take a temperature, and third one is your pressure. If one or more or all the reactants or products are gaseous, then it plays very important role, pressure. Okay, if it involves pure liquid or solid, then pressure has no role. But other two factors, all other two factors are responsible in all the cases. Fine. Now, if we alter this, okay, concentration, temperature, pressure, how our equilibrium will shift or we can get the more yield. Okay, so that we will see one by one, and prior to that we will talk about a very important principle, so which will give the direction for how to approach an equilibrium to alter it in a particular direction to get more and more product, and that principle we call it as what? Le Chatelier's principles. Let us see that one. Le Chatelier's principle. Okay, prior to going for its meaning, okay, try to understand that. A reaction when it establishes an equilibrium. Okay. At equilibrium, if you are maintaining the temperature will be maintained constant and concentration will not change with time. Okay, pressure will not change, alter. Everything will remain constant. Now suppose if we vary any one of these factors, temperature, pressure, concentration, okay, or all three together or any one of the factors, then that puts the stress on the equilibrium. Okay, and when it puts the stress on the equilibrium, then what happens? Equilibrium will try to re-establish itself in such a way that, or the reaction either will shift in the forward direction, reaction will shift in the backward direction. That depends what type of stress you are applying on that. Somehow what it will do, it will re-establish new equilibrium. Okay, to overcome the stress what you have applied in the form of concentration change, temperature change or pressure change. And that we call it as what? Le Chatelier's principle. Okay, so let us define that one. Any factor such as temperature, concentration, or pressure which influence the equilibrium or altered, then that puts the stress on the equilibrium and the reaction will adjust. Reaction will adjust in such a way that to overcome the stress. Okay. Any factor such as temperature, concentration or pressure which influence the equilibrium, if are altered, okay, then that puts the stress on the equilibrium and then equilibrium will adjust, or the reaction, okay, will adjust in such a way that to overcome that particular stress which is applied on that, and it will re-establish new equilibrium. Okay, so that is, we will take an example and try to understand that one. Okay, so that suppose for example, now the reaction has attained an equilibrium. Now what we have done, the formed product is being removed or concentration of the product is reduced somehow. Okay, then what happens? Immediately the reaction will go in the forward direction because the equilibrium is disturbed by what? Altering the concentration of the product. So therefore it will shift in the forward direction. Similarly, suppose if you increase the concentration of the reactant, then also what happens? The equilibrium get altered or it feels the stress, and to overcome that what happens? It will shift once again into the forward direction. Okay, so therefore always at equilibrium, any reaction is at equilibrium. If we alter these factors, then what happens? It will always try to readjust in such a way that to establish new equilibrium, or it will try to overcome that stress. Okay, and it is very, very important to decide various factors what to be maintained to get more and more yield wherever the reaction is going to attain an equilibrium, and we are found much of product in such reactions. Okay, this Le Chatelier principle we are going to use. Okay, first one is concentration. Okay, in simple way we will try to understand this one. Okay, so now suppose for example you can take A plus B combines to give C reversibly. Okay, we will take equation Q is equal to C divided by A into B. Okay, so this Q comes into picture when you alter the concentration of either reactant or the product. Okay, both we will see. Now suppose what I did is, now the reaction is at equilibrium and we altered or we increased concentration of one of the reactant. Then what happens? Your denominator will increase, denominator term will become large. Okay, when the denominator term becomes large, then what happens? Reaction coefficient becomes lower than Kc, equilibrium constant. Obviously, then what happens? Your reaction will shift in the forward direction. Okay, is it clear? Similarly, now suppose if you increase the concentration of the product, then what happens? Your numerator term becomes larger than your denominator term. So then what happens? Qc becomes greater than what? Kc. So therefore your reaction will shift in the backward direction. Okay, means if you change the concentration of the reactants, the reaction will shift in the forward direction. If you alter, change means what? If you increase the concentration, we can say change means increase in the concentration of the reactant leads to shift in the forward direction. Increase in the concentration of the product at equilibrium leads to shift of the reaction in the backward direction. Now, suppose if I decrease the concentration of the reactants, then also what happens? The numerator term becomes smaller and your Q becomes greater than Kc. So therefore reaction will shift in the backward direction. If I decrease or whatever the form product, if I remove that one, then what happens? Decrease in the concentration of the product will lead to what? Shift in the equilibrium in the forward direction. Okay, so that leads to once again re-establish a new equilibrium. Okay, we will see what with one example. Okay, graphically, let us try to understand that one. Suppose H2 plus I2 are combining to give to HI gas, right? So now say for example H2I2 I have taken and reaction is being commenced. When the reaction attains an equilibrium, you can consider, right? Already the reaction has attained an equilibrium, you can consider here. Okay, it is at equilibrium. This is your HI and this is your H2 plus I2. H2 and I2. Now what you do at equilibrium, I am not altering both the concentration, just hydrogen I have increased. Okay, hydrogen concentration is increased. That leads to what? Okay, when the concentration of the hydrogen is increased, then what happens? The reaction will once again commence, right? And then there is a decrease in concentration of iodine also will takes place. Okay, equilibrium actually it is the state of equilibrium we expect, but a decrease in the concentration of the I2 also is observed and decrease in the concentration of the hydrogen is also observed. Here what happens when you alter the concentration of the hydrogen, then the concentration of the HI also increases. Okay, once again re-establishes the equilibrium. So this is your S2, this is your I2 and this is your HI after altering the concentration of the one of the reactant. Similarly, if you increase the concentration of HI, then what happens? The shift in the backward direction will take place. Means 4 conditions you should remember. Either by increasing the concentration of reactants or decreasing the concentration of product, the reaction can be shifted. Reaction you can call equilibrium. Equilibrium can be shifted in the forward direction. Make note of this point, forward direction. Okay. Similarly, increasing the concentration of the product, decreasing the concentration of the reactant, the reaction will be shifted or equilibrium will be shifted in the backward direction. You should remember that. But always we are fond of product. Make sure that this point is very important. You should remember that either you increase the concentration at equilibrium of the reactants or you remove the formed product. Hence leads to decrease in the concentration of the product. Shifting of the equilibrium will take place in the backward direction. Okay. So that is how the concentration is going to influence what? Equilibrium, shifting of equilibrium in either direction. Okay. The next we will see how the pressure is going to play an important role, okay, on the equilibrium. If the reactants and products both are gaseous at equilibrium, or any one of the product or reactant, if it is gaseous, then pressure plays a very important role. Okay, alteration of the pressure, increasing or decreasing, lead towards shifting of the equilibrium in either direction. Say for example, there is a decomposition of calcium carbonate. We are fond of preparation of calcium oxide, which is one of the important component of cement. So therefore we need to manufacture this large scale. So therefore gas is there. Okay. So now in this reaction, right, as the reaction progresses, then what happens? Pressure increases due to this gas. These two are solids. You should remember. It's an heterogeneous equilibria. As the reaction progresses in the forward direction and establishes equilibrium, then pressure of the reaction will increase. So therefore, as the pressure increases, and that is due to CO2, which is on the product side. So therefore, if you lift or if you enhance the volume, increase the volume, then what happens? The equilibrium will shift due to decrease in the pressure in the forward direction. Okay. So here we have to, during the reaction in the forward direction, if the pressure is increasing, okay, pressure increases when reaction goes in forward direction. So then if you decrease the pressure by altering the volume, okay, then we can make the equilibrium to shift in the forward direction. This is one point. Second point is, now suppose if you have H2 gas plus I2 gas to give 2 moles of HI gas. Now, as 2 moles of reactants combine to give 2 moles of product, then there is no net change in the pressure during the reaction. When there is no net change in the pressure, if you alter the pressure, there is no impact on this equilibrium. Means alteration of pressure will not affect the equilibrium when the number of moles of gaseous reactants and number of moles of gaseous products are same, okay, at equilibrium. So therefore here pressure cannot alter this one, or it cannot act as a factor to alter the equilibrium. Now suppose you take your formation of ammonia and 2 plus 3H2 to give 2 moles of NH3. Now you see number of moles of reactants are 4, number of moles of products are 2. So therefore, as the reaction progresses, pressure goes on decreases if it goes in the forward direction. Means during the reaction there is a decrease in pressure, right? But which is due to what? Due to formation of 2 moles of the product. Okay. If you want more and more product, then according to Chatelier principle, you have to increase the pressure. Okay. More and more pressure if we apply, then the shift of equilibrium will take place in the forward direction or in the direction of the formation of ammonia, we call. And next important is that if the product is high, okay, as we have seen in the calcium carbonate or all the gaseous reactants we will take. Say for example, PCl5 undergoes decomposition reversibly to give PCl3 gas plus Cl2 gas. Now what happens? As the reaction goes in the forward direction, pressure is going to increase. Now if you want to shift the equilibrium in the forward direction, then always you have to decrease the pressure by increasing the volume or any other means. Okay, so that three conditions we should remember. Whenever the pressure increases when the reaction is in the forward direction, or formed products are gaseous or more number of gaseous molecules than compared to reactants, so then always it will equilibrium will shift in the forward direction by what? Decreasing the pressure. And if number of molecules of reactants and products are same, gaseous reactants and products, then there is no effect of the pressure on the equilibrium. And if after combining of the reactants, gaseous reactants to give the product, if the number of moles of product are less, reactants are more, then always the reaction can be shifted in the forward direction by what? Increasing the pressure. And last important point is, that is temperature, we will see. Well, during any reaction, the energetics of the reactions, how it will be, the reaction will occur either by absorption of the heat energy, okay, that is we call it as endothermic reaction. If it is endothermic in the forward direction, then always remember in the backward direction it will be exothermic, okay, or in the forward direction if it is exothermic, then in the backward direction it is always endothermic. So therefore always we are fond of what? Shifting the reaction in the forward direction. So therefore, suppose in the forward direction, if the reaction is exothermic, always remember that reaction can be brought by altering the temperature, that is decreasing the temperature, the reaction will shift in the forward direction. Okay, if the reaction is exothermic, okay, then in forward direction, okay, we will take example forward direction, then always decreasing temperature leads to shifting of equilibrium. Shifting of equilibrium in the forward direction. Okay, and if it is endothermic in the forward direction, then equilibrium can be shifted in the forward direction by increasing the temperature. If you increase the temperature, then we can shift in the forward direction. Okay, you should remember these things. Endothermic in the forward direction, if you increase the temperature, then equilibrium can be shifted in the forward direction. Okay, if it is exothermic in the forward direction, if you decrease the temperature, then it will be shifted on that. Overall, we will summarize all these three factors, okay, how they influence on the formation of ammonia by Born-Haber cycle, and how Lee-Chatelier principle plays an important role. We will see that. So, optimization of conditions in the manufacturing of ammonia, okay, using Lee-Chatelier's principle. So how we can optimize the factors, we will see that. N2 gas combines with 3 moles of H2 gas to give 2 moles of NH3 gas. Okay, so first we will see concentration according to Lee-Chatelier's principle. We know that we can liquefy this ammonia and we can separate it easily. So means decreasing the product, decreasing the product concentration at equilibrium. Okay, we can shift the equilibrium in the forward direction. This is one point, decreasing the product concentration at equilibrium. And second one is increasing, means we should add more and more nitrogen and hydrogen, increasing the concentration of N2 and S2 at equilibrium. These are in relevance with the concentration, how we can optimize more and more production of the ammonia. Second one is pressure. As we know that after combination or when the reaction commences, then pressure goes on decreases because 4 moles of reactants are there and 2 moles products we are getting. So therefore, by increasing the pressure, so we can make equilibrium to shift in the forward direction. And we should remember enthalpy of reaction is negative, means it is exothermic. So therefore, temperature, what we have to do is, we have to decrease the temperature. Okay, decrease the temperature. We have to increase the pressure, decrease the temperature, remove the product, add more and more reactants. Then what happens? Manufacturing of ammonia will be more easy, we can say, or more and more ammonia we can get. Now the problem is, if you decrease the temperature, then energy of activation problem will come. Okay, to overcome that, what you have to do is, to decrease its energy of activation, we have to use the catalyst. Okay, catalyst such as iron is used, or iron oxide we are going to use as catalyst, and molybdenum is used as promoter. Okay, so these are the conditions according to Lee-Chatelier principle maintained to get more and more ammonia. Okay, I hope you have understood all these factors which are going to influence equilibria. Another 2 factors we will see in 2 minutes. That is, one is that how the addition of inert gas is going to impact on the equilibrium. If you add inert gas, it will not increase the partial pressure of the reactants or the concentration of the reactants. It will not alter both, either partial pressure or it will not alter the concentration. Hence, if you add inert gas to the reaction at equilibrium, it will not change the equilibrium concentration. Okay, or it will not alter the equilibrium. Make note of this point. And last one is, what about catalyst? Is it going to influence the equilibrium? No, catalyst will not alter the equilibrium concentration. Catalyst only helps in attaining the equilibrium equilibrium earliest or fastest. Okay, so we can bring the equilibrium can establish readily or rapidly, but not the concentration are going to alter by the presence of catalyst. These 2 important things you should remember. Means catalyst and your inert gas addition will not have any influence over the shifting of the equilibrium in either direction. Okay, I hope you have understood the factors, Lee-Chatelier's principle. Okay, thank you for watching, and don't forget to subscribe. In the next video, we will start with ionic equilibria. Thank you.